Hey, good morning, everybody. This is Mr. Ainsworth again, and we are going to get into activity 3B4 here in MRWC. And yes, this is a prep, which means it's a fluency moment for activity 3B4. And yes, I'm going to be talking about structure and all the different important skills in the lesson, or excuse me, in the activity, okay? And so what we want to do is recall the difference of squares, the structure of it. And I've talked about this before, but let's outline it again. So let's put this big bold in red, all right? We're talking about something like this. So when you have a binomial a minus b and you're multiplying it by another binomial, a plus b, okay, so notice that a and b are the same in both binomials, but one is a sum and one is a difference. Okay, what do you get? Okay, and I could write out what the difference of squares is, okay, and we'll talk about the structure and the pattern. All right, but let's develop it one more time. Okay, so let's distribute. Okay, so you distribute a times a, and again, this is using FOIL or the distributor property here, is a squared. Okay, obviously a times a is a squared. A times b is obviously ab. That's usually the way it goes. All right, and negative b times a, that's negative ab. Negative ba, negative ab. The order does not matter there, so I'm going to write it as negative ab. All right, and then negative b times negative b is a negative b squared, or what's commonly known as a minus b squared. Okay, now opposites obviously add to 0 here. If you have AB and you subtract AB, then you have nothing remaining. You have 0 left over. So what we get left over, all right, is a squared minus b squared. And we call this the difference of squares. All right, and so this is equal to a squared minus b squared. And that's why we call it a difference of squares, because difference obviously means subtract of two squares. A squared is a square and b squared is a square, so you just square both and subtract. Alright, so that's the key concept right here. Alright, you square both terms and subtract. Square both terms. Alright, and then subtract the results. It's so simple. When you see the structure, and I'm talking about when you see a minus b times a plus b, which is the structure. Okay, this part right here is the structure. Alright, all you do is square both terms, and I'm talking about a and b, and you subtract the results. Square both and subtract. That's it. So you identify the structure and then apply the idea. Okay, so let's take a look at that. So root 7 minus 11 times the quantity root 7 plus 11. Okay, so obviously this is a minus b, all right, times a plus b. There's your structure. So it has the same structure as the difference of squares. So all you have to do is square both and subtract. So you got to take root 7, the square root of 7 squared, all right, minus the square root of 11 squared. And if you want to write this with the parentheses, you may. I mean, some people write it like this: the quantity of the square root of 7 squared minus the quantity of root 11 squared. It's the same thing. Okay, so you're squaring both terms and you're subtracting. Well, when you square root 7, you get root 7 times root 7, which is 49, and root 49, and root 49 is 7. In other words, the square cancels out the root because the inverse operations, and you get 7 here. The square root of the square of root 11 gives you 11, because root 11 squared means root 11 times root 11, which is the square root of 121, which is 11. The fastest way to do it, though, is just to cancel the square and the root out, and you get the number inside the radical called the radicand. Okay, and it's called 11, and 7 minus 11 is negative 4. Okay, so when all said and done, you get negative 4. Now, if you're lucky, life is that simple, and you only have a single root. But sometimes roots have coefficients. Okay, and when you do, there's a little bit. You got to approach it slightly differently. I mean, in the same method overall, but you have to know one more thing about how to deal with radicals. So when you have a plus b, all right, times a minus b, where a and b are the terms, 3 root 5, and b is 2 root 3. Notice we have the same structure. Okay, so when you see that, you know this is equivalent to a squared minus b squared. I'm talking about something squared minus something squared, a difference of squares. So whenever you see that, you go, okay, well, the first term is 3 root 5, so let's take 3 root 5 and square it. And the second term is 2 rad 3, and then you got to square that. So this is a little bit more challenging example because you got to square a radical that has a coefficient. And luckily for us, you know that we've done this before. So you square both the 3 and the root 5. Again, from, let me see, from algebra 1, let's say. Let me go up here to the top. The square of, when you square a times b, that's equal to a squared times b squared. That's from algebra 1, believe it or not, from 8th or 9th grade. All right, algebra 1 property. That's a 1 right there. I meant that. Algebra 1, okay? The square root of a product is a product of the squares. All right, so 3 squared is 9 times the square of root 5 is 5. The square of 2 is 4, because 2 times 2 is 4. And you times the square of root 3, which is 3. So you get 45 minus 12, which is a total of 33. Okay? And that's how the game is played. So you want to see the structure in the expression and identify it as a difference of squares. And I'm talking about this stuff in red right here. This is called the difference of squares. Right here, because difference means subtract, right? And a squared and b squared are obviously squares. Let me just say it out loud, you can see it. Okay, and that's all there is to it. So what we want to do in this is go through all the different kind of important skills and structures needed to be successful in this lesson here, because this, my friends, is not easy. All right, so pay attention because you're about to go through it. So let's go through part 2 here, like numbers 3 and 4 here, how we simplify radicals, which are just roots. Okay, before let's underline that, before we combine like terms, because root 50 and root 32 are not like, so you can't combine them as they are. A very common misconception is that you could take root 50 minus root 32 and get root 18. Okay, and that is definitely not the case. Okay, you can't subtract unlike roots. So root 50 minus root 52 is not equal to the square root of 18. You can, it's a no. Okay, no. It's a common misconception. I see this all the time. Okay, people think you can add and subtract unlike roots, so you can't do it. Just like you can't add and subtract unlike variables, you can't add and subtract unlike roots. So what you have to do is you have to simplify. So let's highlight that word. You got to simplify before, okay, you combine, because you can't combine at the moment. You just can't do it. It's a no. Okay, definitely a no. So listen, factors of 50 are 5 and 10 and 25 and 2, and you want to pick 25 and 2 because 25 is your square. So 2 times root 25 times root 2. Now 32, well, 32 has a lot of factors, right? So this is 1 times 32, 2 times 16, 4 times 8, right? No, not 6. 4 times 8, that's it, right? Okay. So we'll use the factors of 2 and 16. So root 16 times root 2. Why? Because 16 and 25 are squares. Very importante, okay? You cannot, you want to pick the factors that involve squares. In fact, you want to pick the factors that involve the biggest square. Like 16 is bigger than 4, so I would choose 2 and 16 versus 4 and 8, because 16 is obviously a bigger square than 4. Okay, I'm talking about these two numbers right here. So let's keep on going. So this is equal to 2 times 5 times root 2 minus 4 rad 2, which is obviously equal to 10 rad 2 minus 4 rad 2. Let me see, if you start off with 10 rad 2s and you subtract 4 root 2s, I think you have a total of 6 root 2s remaining. Why? Because 10 minus 4 is 6. Okay, you subtract the coefficients. Okay, all you do is subtract the coefficients of the like terms. Okay, and that's how you deal with variables too. Like, for example, if I had 10x minus 4x, I would say that's equal to 6x. It's the same thing. You subtract the coefficients. You act with variables the same way you do with roots. Or excuse me, vice versa. You act with radicals the same way you do with roots. Ah, I got it backwards again. You act with roots the same way you do with variables. Okay, I'm getting a little goofy right now. Okay, so that's okay. Goofiness is good. All right. Now, this one's similar here. So if you want to pause the video here, okay, pause and play through the video. That's probably a good thing to do. Pause and play. Just don't, sit there and just watch and take notes. Why don't you interact, okay? If you think you got it, pause the video and then work it out and then press play when you're ready. All right, so go for it. All right, go for it. I need to take a sip of water here. I always got to stay hydrated when you're doing a lot of math because hydration is good. Okay, here we go. I'm going to assume you did it. So root 27 is the square root of 9 times the square root of 3, which is 3 rad 3. Root 12, all right, well, that's root 4 times root 3, which is 2 rad 3. So you got to simplify the roots. All right, before, look at that, I said before combining like terms, because you can't simplify root 27 and root 12 as they are, because they're unlike roots. Okay, so here we go, 4 times root, 3 root 3. Well, root 9 times root 3. I'll step it out. And then minus 5 times root 4 times root 3. If I was going to step it out, this is the way I would do it. Well, I get 4 times 3 times root 3 minus 5 times 2, because root 4 is 2, times root 3. And if I'm going too fast here, again, this is a video, right? So hit the pause button, people. I always get surprised when people say, "Oh, Aynesworth, you went too fast." Or they're watching a Khan video, like Sal Khan from the Khan Academy, and they're going, "Oh, he goes too fast." No, he doesn't. There's what's called a pause button and rewind button, so use it. Okay, so you have 12 root 3 minus 10 root 3, and as I said before, check this out. Okay, 12 minus 10 is usually 2. Okay, so this is equal to 2 rad 3. Why? Because if you start off with 12 roots of 3 and you subtracting 10 roots of 3, well, you have 2 roots of 3 remaining. All right, so you just subtract the coefficients again. So it's not as complicated as you guys think, as long as you understand the basics and you have a good fundamentals down. All right. Now let's talk about rationalizing the denominator. Okay, the denominator is the term in the bottom. Okay, bottom versus top. Okay, so here we go. Now, why do we want to do that? Well, there's a convention in math that says, okay, if you see a root in the denominator, which is not an integer, okay, because remember, rational form is an integer over an integer, then you need to rationalize it, because root 3 is not an integer. You can't express root 3 as an integer. I mean, there's just no way to do it. It's 1.7 something. So notice the denominator is not an integer, and therefore we got to rationalize it to make it integer over an integer, because it's not that way. All right, so let's take the expression 2 divided by 5 rad 3, and let's multiply it. And let's get creative here. We want to multiply root 3 by something to get an integer. Well, root 3 times root 3 is just 3. So it makes sense just to multiply it by rad 3 over rad 3. And you've talked about this a little bit in geometry. We talked about rationalizing then. Maybe not in Algebra 1, but when I teach geometry, I teach this. And you saw it in Algebra 2, and you saw it in Pre-Calc, and now you're going to see it now. So you guys are in another Pre-Calc course called MRWC, all right? And it's just another Pre-Calc course, just taught differently. Taught in a really cool fashion, by the way. Okay, so you have 2 times rad 3, which is 2 rad 3. That's pretty obvious. Root 3 times root 3 is 3, so I have 5 times 3 here below. So my answer is 2 root 3 divided by 10. All right, and that's all there is to it. So now you try it. All right, try number 6. All right, pause the video. Again, if you really want to test yourself and to see if you guys understand what's going on, you'll pause and play through the video versus just copy and take notes. I mean, don't be robotic, okay? Be a learner, okay? And use the videos properly in that you'll learn something, but you also test your understanding as well. Okay, so I'm going to assume after all that you have tried this one. Okay, so root 2 times root 2 is 2. So I'm going to multiply this by rad 2 over rad 2. Okay, notice that I don't need to multiply by full rad 2, just by rad 2. So up top I get 3 rad 2. Down below I get 4 times 2, which is 3 rad 2 over 8. Okay, or divided by 8. Now the first two are fairly simple numbers, 5 and 6. Now when it comes with the binomials, you use what's called the conjugate. Okay, so what am I saying? So conjugates. Conjugate of 3 plus rad 2, or a plus b, or the square root of, actually, let's say a plus the square root of b, let's say that. The conjugate, don't put an equal sign, put an arrow. The conjugate of this is the difference. So the conjugate of a sum is a difference. So a minus root b, let's say. So the conjugate of 3 plus root 2 would be 3 minus root 2. Oops, sorry about that. I don't know why it does that something. So, alright, so, oops, gotta write down the right expression. So 2 divided by 3 plus the root 2. And now I'm going to multiply by 3 minus rad 2 divided by 3 minus rad 2. Remember, this is illegal. This stuff in red, we call these forms of 1. Form of 1. Why? Because anything divided by itself is 1. Root 3 divided by root 3 is nothing more than 1. And when you multiply something by 1, you're not changing its value. That's why this is legal. If you multiply any number by 1, you're not changing the value of it. So this thing that we're doing called rationalizing, okay, is legal because I'm not changing the value. If I did, I would not be doing this. Okay, so 2 times this. So I have to distribute through. So 2 times 3 is 6, and 2 times root 2 is 2 root 2. Oops. There we go. Now you gotta multiply this. Now guess what? This is called the difference of squares, guys. Now, difference of squares, and we already talked about that above. Okay, so let's go back up here. And this is the reason why we started off with this. Now, difference of squares, when you multiply a sum and difference of the same terms, you just square both and subtract. That's all you do. And so, well, obviously we're building up skills. So this is 3 squared minus the square root of 2 squared. So you get 6 minus rad 2 up top, and you get 9 minus 2 on the bottom, the denominator, so you end up with 6 minus rad 2 divided by 7. And if you want to write it in another form, you simply divide both by 7. So some people write it like this, not that you have to. Okay? For me, this right here is good enough for me. Okay? If some teachers, they want you to split the fraction. Okay, so that's depending on the teacher, but for me, 6 minus rad 2 all over 7 is fine with me. Okay, now I want you guys to do it. So take 5 divided by 1 minus rad 3. Go ahead and multiply it by another form of 1. Alright, pause the video and go for it. Okay, I'm assuming that you went for it, so I'm going to multiply it by 1 plus root 3. Notice that I put parentheses around all the binomials. So 5 times 1, when you're distributing through, you get 5 plus the 5 rad 3. And again, the denominator is a minus b times a plus b. So all I do is square both and subtract. So square both. Notice the squares and notice the minus sign. So I get 5 plus 5 rad 3 up top in the numerator. Alright, and I get 1 minus 3 in the denominator, so all said and done, I get 5 plus 5 rad 3, all divided by negative 2. And if you wanted to, you can take negative 5 halves and then minus 5 root 3 divided by 2 by dividing both the terms in the numerator by negative 2. So if you want to do that, fine. But like I said, if you want to, just keep it right here like this. That's fine with me. Okay. Yeah, so number 7 and 8, a little bit more challenging than 5 and 6, but again, this is done in Algebra 2 and Pre-Calc, and yet you're not in another Pre-Calc course. So you guys have seen this all before. These were skills developed in Algebra 2 and Pre-Calc, and so just practice them, get them fresh in your memory, and get good at them. Okay. One of the reasons why people take this course is to get good, so that if you do go into college, all right, and take calculus, well, you're better prepared. Why? Because you have a better understanding of the structures and, you know, the patterns, the structures, and all the arithmetic, and you have a better understanding of that. So when you go into a higher course like calculus or something else that's higher than this, all right, you're going to be better prepared. Now, sometimes you want to rationalize the numerator. So this is just developing the same skill that we did before, but we're applying it to the numerator as opposed to the denominator, because you can tell right now that the numerator, 1 minus rad 2, is not an integer. Okay, root 2 is not an integer. So to make it rational, well, you do the same thing as we did before, but you do it up top. So we're going to take 1 minus rad 2 over 4. I'm going to multiply it by 1 plus the rad 2 over 1 plus rad 2 in a form of 1. This is called a form of 1, right? Because, well, anything divided by itself is 1. 1 plus root 2 divided by 1 plus rad 2 is just 1. It's called a form of 1. So get used to that, because it happens all the time. It's just a little mathematical thing. That's all it is. Okay, so now up top is the difference of squares. This is a difference of squares again, and again it's a minus b times a plus b, so all you do is square both and subtract. Okay, so I square the 1 and square the root 2, and then 4 times 1 is 4 minus 4 rad 2, or excuse me, plus 4 rad 2. Okay, obviously I just distribute right there, so I get 1 minus 2 divided by 4 plus 4 rad 2, which gives me negative 1 divided by 4 plus 4 rad 2. Now you try it. Take 2 minus rad 3 divided by 5 and multiply it by a form of 1. Okay, pause the video. Again, pause and play through the video. All right, be a good learner. All right, go for it. Okay, let's check your understanding. So we have the conjugate of 2 minus root 3 is 2 plus root 3 divided by itself. Again, these are binomials, so give them a hug. All right, this is a difference of squares up top. So we have a minus b times a plus b, which is a squared minus b squared. So you have to do that. So you take 2 squared minus the square root of 3 squared. Again, this is a difference of squares. You got to see the structure going all the way back to the very beginning. I'm talking about the first 2 examples. All you do is square both and subtract. Alright, so let's do it. Okay, and then 5 times 2 plus root 3 is 10 plus 5 rad 3. That's simple, you just distribute through. Boom, that's easy. Up top you get 4 minus 3, down below you get 10 plus 5 rad 3. Alright, and you get 1 divided by 10 plus 5 rad 3. Alright, so that's how you rationalize the numerator, and in the activity they're going to ask you to do all these things. So just go with the flow and get good at it, and so you're successful in the activity. Alright, let's take a look at how to apply powers of the roots. Now, root 3 to the 5th power. Okay, now if you don't know how to handle that, there's many ways to do this, okay? Well, not many ways, just a few ways. But one way to do is expand. So this is the long way to do it. There's a lot shorter, efficient ways, but you know, you could take the square root of 3 times 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 the square root of 3 and simplify it this way. I'll show another way here in a minute. Okay, so there's this way here. Okay, and here you get 3, and here you get 3, and then here, well, that's just root 3. Root 3 times 3 is 3, and then you get 9 times root 3. That's one way to do it. You can expand and simplify. For most people, I would say, and I would guess, that this makes more sense. All right. Now, the other way to do it is understand that this is the harder way to, or a different way to do it. But this, the root is the 1/2 power. So one way to handle this is by taking 3 to the 1/2 power to the 5th power, and that's equal to 3 to the 5/2 power, because 1/2 times 5 is 5/2. And that's equal to 3 to the 2.5 power, and that's going to be equal to 3 squared times 3 to the 1/2, and so that's 9 times root 3, and you're done. So if you want to do it this way here by using exponents, this is right here by using exponents, you can. I would think that most people would feel comfortable expanding and simplifying. I don't know. It depends on how you think. Okay, so you decide. Okay, whether you want to use exponents or expanding, doesn't matter. Go ahead and pause the video. Try number 12. Okay, so I'm going to expand and simplify just because I think that that's probably what you guys did. There's 7 of them now. There's 4, oops, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so here I get 2, here I get 2, here I get 2. Okay, 2 times 2 times 2 is 8, and so my answer is 8 rat 2. And that's all there is to it. You just have to kind of go with the flow and, you know, either expand it or use your exponents, whatever method you prefer. But whatever you do, okay, and method doesn't matter to me as long as it's valid. All right, you're going to get 8 root 2. All right. Okay, so no. Let me see. Okay, so next one here, multiplying roots with coefficients. Here we go. Now notice the expressions are the same, but I got different methods. So first method here, what we're going to do is we're going to simplify the roots first before we multiply. So let's write that out. So we're going to simplify roots first, all right, before multiplying. You know, some people would take this strategy. And the second method is you can just flat out multiply and then simplify. So method 2 is multiply first, all right, and then simplify. And now I'm going to do it both ways, and then guess what? You get to choose. Which method do you prefer? Okay, and we'll talk about that after we do it. Okay, so the only way you can tell which method you like is to do both of them and then decide, you know, which one you like. All right, so let's do it. All right, so here we go. We're gonna simplify. Well, you can't simplify root 6, but you can simplify root 18. I mean, factors of 6 are 2 and 3 and 1 and 6, and nothing is no factors is square. So 1 times 6, 2 times 3, there are no squares. So you can simplify it. Now root 18 or 18, that different story. So 18 is 1 times 18, 2 times 9, 3 times 6. So 9 is your square, so you can simplify the root 18. Well, you know what? You got well, there's a factor of 6 here too. So you know what? Instead of using 2 and 9, I'm going to scratch that. I'm going to use this one because I see a 6 over here. So watch this. So 3 root 6. Again, you got to explore first, right? 2 times root 6 times root 3. Because root 6 times root 3 is root 18. Okay, so these are equivalent. Okay, that's the only thing I did. Now, why did I pick root 6 versus using the factors of 2 and 9? And the reason for that is because I see a root 6 here. So I'm going to reorder. So I'm going to group up the 6's. So 3 times 2, and then group up the root 6's, and then leave the root 3 over here. So just reorder it. If I can spell, that'd be nice. Okay, so reorder. Okay, so here we go. We got 6 here, we got 6 here, and you got root 3 here. 2 times 3 is 6. Root 6 times root 6 is root 36, or 6. Okay, and then right here, well, I just have 36 root 3, and I'm done. So if you want to factor or simplify or factor, actually, let me write down factor here. If you want to factor or simplify first before multiplying, you can do that. And you know what? It's pretty simple. I think everybody can factor 18 to root 6 times root 3, knowing that there's a root 6 over here on the left. Okay, so getting creative versus being robotic and just doing it sometimes is nice. Remember that. Okay, now if you just flat out multiplied, again multiply first, this is what would happen. I would have to go 3 times 2 first, and then I have to take root 6 times root 18. Because you can only multiply the non-roots and then the roots. So here I get 6 here. Obviously 3 times 2 is 6, right? Okay, now here, alright, now 6 times 18. If you multiply, and I'm only doing this just because I can do this in your head, but I don't know if you guys can. Alright, so you got 48 here, so it's 108. Okay, so a lot of people would do this, and in my opinion this is the harder way, but you know, a lot of people do this. Okay, and then you gotta simplify 108. You gotta simplify this. So then you gotta take 108 off to the side and start factoring. So 108 divided by 2 is 54. Divided by 2 is 27, divided by 3 now is 9, divided by 3 is 3, divided by 3 is 1. And then you got to find squares involved, and I see a square here and here. 2 times 2 is 4, 3 times 3 is 9, and then 4 times 9 is 36. So I see 36 times 3 as my factors. I talked about that in a prior lesson. Okay, you want to find the biggest square. Okay, so you have 6 times root 36 times root 3, and that's 6 times root 3, and now it looks the same as the one on the left. Alright, look at this, they're the same. So which method do you prefer? Okay, there's a question. So which method do you prefer? Do you prefer method 1, getting creative, or do you just want to be robotic and just multiply everything together, all right, without much thought about it, and then do it that way? I mean, you could do whatever you like. You get the same answer, all right, but which one's more efficient? In fact, let me write that out. So which method is more efficient? Okay, less steps. Easier. Which one has less steps? Which one's easier? Which one, you know, can you do method 2 all in your head without this factoring? Can you do all that without any factoring on the side, without any multiplication, without any factoring? Can you do that? You have to ask yourself that. That's totally up to you, and that depends on the person. You know, everybody's different and has different mental capabilities, so you'll have to make that decision on your own. All right, number 14, here we go. Method 1, so let's just, in 24 there's a factor of 3. I know that 24 is 3 times 8, so 24 is 3 times 8. So watch this, I get 2 root 3 times 5 times root 3 times root 8. I'm factoring first. Now reordering, I get 2 times 5 times root 3 times 8. All I did is reorder. Okay, and here to here I factored. Just factor the number. 8 is obviously 3, excuse me, 24 is 3 times 8, so you factor it first. And now you figure it out. Okay, here is 10, 2 times 5 is usually 10. And, oh, what did I do there? No. Oh, I misread it here. Root 3 times root 3 times root 8. I forgot root 3. So I gotta, here, let me write this down. So root 3 times root 3 is right here, and then I got that root 8. Okay, so this is only one of many ways to do it. And then you get, here you get 3, so times 3. I have to factor the 8 again here. So right now I have 30 root 8. But again, this is root 4 times root 2. So I have 30 times 2 times root 2, which is 60 rad 2. Okay? So that's one way to do it. You don't have to do it that way. You could just flat out multiply. So 2 times 5, okay, and then root 3 times root 24. Here I get 10, and then here I get the square root of 72. 3 times 24 is 72, and then I have to go off to the side and factor the 72. The question is, do you guys know what 72 divided by 2 is? And it's 36. Divided by 2 is 18. Divided by 2 is 9. Divided by 3 is 3. Divided by 3 is 1. And then you're looking for squares. So I see one here. I see one here. I see a bigger one here. So my factors of 72 are 36 and 2, which we saw in the very beginning. So this is 10 times root 36 times root 2. And this is 10 times 6 times root 2. And that's 60 rad 2. So there's different ways of doing things. So sometimes the second method is faster, and sometimes the first method is faster. So it all, depends on what makes more sense to you, and it also depends on the number sometimes, and in what's called experience. Okay, so you guys are going to just have to flat out practice like a madman and get good, so you can figure out what's best at whatever given time, depending on what you're given. All right. Next concept, squaring a binomial. Here we go. Now this is cool. Not too many people are taught this in Algebra 1, but I do. I teach my students how to square a binomial without distributing a FOIL, although it's developed through distributing or the FOIL method. Okay, so I'm gonna use the distributive property in the FOIL method to develop the idea, but when I work these out, I am not going to do that. I'm going to do it the most efficient way because I'm going to look at structure. Look at structure. Okay, and again, a lot of this lesson in MRWC, especially this one here, we're starting to look at structure of numbers, and that's really, really important. So here we go. Let's develop it through the distributive property first. So we're going to take a plus b times a plus b because that's what it means. Okay, and let me pause right now. Let me go off to just in the margin here. Okay, a plus b times a plus b, all right, does not equal to a squared plus b squared. This is a common misconception. Okay, any teacher have seen this a billion times. Okay, so let's highlight that. This is a common misconception. It is not equal to a squared plus b squared. Okay, it's just flat out not. I'm going to show you. Okay, so here we go. All right, we're going to use the distributive property. A times a is a squared. A times b is ab. B times a is ba, which is the same thing as ab. So I'm going to rewrite it as ab so that you guys understand that they're like terms. And then b times b is obviously b squared. And notice how I lined up the like terms too, by the way. Not everybody does that, but I do, just to show you that you can only combine like terms. Okay, so what do you get? You get a squared plus 1, let me see, 1ab, look at this, 1ab plus 1ab is 2ab. You add coefficients, 2ab. A lot of people don't think like that. I see a lot of a squared b squareds right here, and that's definitely not the case. If you have 1ab plus another ab, well then you have 2 ab's total. Okay, because 1 plus 1 is 2. All right, and then plus b squared. And this is right here, this is the structure that I'm talking about. So how can we use this to our advantage? So a and b are the terms in the binomial. So what this structure is telling me, okay, and I'm going to, this is the translation now. So it says take the first term a and square it. So square first. 2ab means, ab means times, so you multiply a times b and then you double it. So you multiply and double. So you multiply and double. Double means times 2, right? Okay. And then you take the last term b and you square it. So square last. And that's what I think in my mind. Square, multiply, double, square. Say it out loud. Square, multiply, double, square. Square, multiply, double, square. And that's how, teachers and other mathematicians, just in general, square binomial without any foiling, without any distributor property, without multiplying, by writing it all out. Okay, you just do it. Okay, you square, multiply, double square. So let me demo. Okay, so you take the first term and you square it. Okay, you square 2x and you get 4x squared. 2 squared is 4, x squared is x squared. You multiply the two terms. 2x times negative 3 is negative 6x. But if you double that, all right, you get negative 12x. And so I'm going to write down a minus 12x here. And then you square the last. When you square negative 3, you get positive 9. Okay, and remember, the plus b squared, it's always positive. So you square, multiply, double square. When you take 4x squared, you get 16x squared. So you start off by taking 4x and squaring it, you get 16x squared. You multiply 4x times 5 to get 20x, and then you double it, and you get 40x. So plus 40x, and you square the 5 to get 25. You square, multiply, double square. You square, multiply, double, and then you square. Square, multiply, double, square. Those dashes are dashes, not minus signs, okay? If you want to put commas in, go ahead and do that, like I did up here at the top. Okay, you square, multiply, double, square. Now here, you square the root 7 to get 7. Remember that. The square of root 7 is just 7. Root 7 times 3 is root 21, but then you double it and you get root 21. Excuse me, 2 root 21. So you take root 7 times root 3, you get root 21, and then you double it and you get 2 rad 21. Alright? Root 7 times root 3 is equal to root 21, and then you double it, so you multiply by 2, and then you square the root 3, alright, and you get 3. I just showed you the steps up there. Square, multiply, double, square. And then you get plus 3, and then you simplify. 7 and 3 is usually 10, so you get 10 plus 2 root 21. Alright, now you try it. Pause and play. Pause and play. Let's check your work. The square root 5 gives you 5. Root 5 times negative root 2 is negative root 10, but then you got to double it and you get negative 2 rad 10. And you square the root 2, a negative root 2, and you get a positive 2. 2 and 5 is 7, so you get 7 minus 2 rad 10. 7, all right, minus 2 rad 10. And you can't combine those because 7 and 2 root 10 are unlike, so you cannot combine. I didn't mention that in the number 17, but you cannot combine. Okay? Unlike terms. I'm talking about the previous ones. Okay. Let's highlight that. So that's an important point. All right. Almost done with all the skills. Okay, last two. And this is a challenge section here. Now, these two right here, 19 and 20, are just like, well, it's just like right here. It's the difference of squares. Okay. Oh, excuse me. I'm sorry. I didn't say. Wait a minute. Let me look at it again. Yeah, one's a plus. Yeah, it's the difference of squares. So let's go back to the very beginning. All right. When you have a minus b times a plus b, you get a squared minus b squared. All right. So you got to look for structure. My computer's getting a little slow. All right. So let's look for structure here. So root 8 minus 2 is here. Root 8 minus 2 is here. That's kind of like your a. Oops. Okay. And then your b. Okay. You see that right here. B is root 3. So we have a minus b times a plus b. Okay. So this is a difference of squares. And that's why I put the title up here, right? Well, that's a crazy start right here. That's better. Okay, so a plus b times a minus b is equal to a squared minus b squared. You square both and subtract. Square both and subtract. That's all you do. And so what looks like very difficult something very difficult is really not. Okay, so here we go. I'm going to take the first term, which is the square root of 8 minus 2. I'm going to square it. And I'm going to subtract the second term, which is root 3, and I'm going to square it. I squared both and subtracted. Look at the minus sign right there. It just so happens that the first term is a binomial. That's the only difference. Now, so this is like two skills in once. When I square the binomial, I have to square, multiply, double square. So this portion right here, I've got to square, multiply, double square. I got to square the binomial, which means I have to square, multiply, double square. Okay, I just did that above here. So if you look right up here, I just talked about that. I squared, multiply, double square. And this is what you got to be thinking, okay? Square, multiply, double square. So let's apply it. It just so happens to be like two concepts in one. So I square the root 8, I get 8. Multiply the 2, I get negative 2 root 8. And double it, I get negative 4 root 8. I got to multiply and double. So negative 2 times root 8 is negative 2 rad 8. And then I double that, and I get negative 4 rad 8. And then I got to square the last term, which is negative 2, and I get 4. So all of this right here, sorry about that. Okay, this first term right here, when I square the binomial, I get all of this. And then I got to subtract the square of root 3, which is nothing more than 3. So that part's simple. Okay, now I got to collect like terms. The 8, the 4, and the minus 3. So 8 plus 4 minus 3 goes first. And then I'm just going to reorder this. So reorder, right? 8 plus 4 minus 3 is written first. I simplify here. 12 minus 3 is usually 9. So I get 9 minus 4 root 8. And I got to simplify further because root 8 is root 4 times root 2, which is 2 rad 2. So this is 9 minus 4 times 2 rad 2, which is 9 minus 8 rad 2. And I'm done. Whew. Okay, so yeah, that's challenging. Okay, that's challenging. I agree. But you know, with a little practice, all right, you can handle it. So from here to here is the simplifying step. All right, and then simplifying some more. So from root 8 is 2 root 2. So again, root 8 is nothing more than 2 root 2. And then obviously 4 times 2 is 8, and so on. And again, if this is too fast, then guys, this is a video. Go back and listen to it again before you go to number 20, because I guarantee you that if you don't understand number 19, forget number 20. So it's always wise, all right, to fully understand something before you move on. So if you have to, listen to the video again on number 19 before you try number 20. All right, if you do, pause the video. Here we go. So this portion right here is A and this is B. So this is A minus B times A plus B, which means that it's equal to A squared minus B squared on the structure. That's called the structure of the problem. And this is what MRWC is trying to develop within you so you can be a good mathematician. All right, so here we go. It's going to be equal to, all right, so the square root of 12 this time minus 3 squared minus the square of root 5 squared. You square both and subtract. Again, it's A squared minus B squared. That's the structure. Now, when you square the binomial, you got to remember what we just did over here on the left. You got to square, multiply, double square. So you square the root 12 to get 12. You multiply the 2, and you get negative 3 root 12. Double that, negative 6 root 12. And then you square the last, and you get 9. So this portion right here on that, when you square the binomial, you get these three terms. And then when you square the root 5, you just get 5. That's easy. Reorder. Just separating the two problems there. 12 plus 9 minus 5 first, and then the minus 6 rad 12 next. 12 and 9 is 21, and 21 right here minus 5. That gives you 16, so you have 16 minus 6 rad 12, but root 12 is root 4. Okay, times root 3. And then when you take root 4 is 2, so you get 6 times 2 times root 3. So all said and done, you get 16 minus 12 rad 3. And again, you cannot combine, okay, because of unlike terms. Okay, 12 root 3 and 16 are unlike terms. And that's all there is to it. The only thing that you guys need to do is get good. And you can't get good by watching me, okay? Seeing is different than doing, all right, in my opinion. And so what I've done is I've modified activity 3B4 a little bit because it is a long, tough activity. And I selected some of them, the majority of them, and I put it in a student-friendly format here. All right, where you get to be able to show your work in a student-friendly way. So you're going to be going through all of these, and of course you're going to be working with your group, and you're going to be comparing your work and talking about it. So when you go into your breakout groups with 3 to 4 or 2 to 3 other people here, you need to discuss the strategy, okay, and the structure. So when you're doing this in your groups right here, discuss a couple things, all right? Discuss, all right, strategy and structure. Okay, method. When I say strategy, I'm talking about method and the structure of it, because some people in the beginning have a hard time seeing the proper structure, and if you don't see it, then maybe your group mates can help you out with it. So keep that in mind, all right? And then when you come back to the main classroom, and work with me, obviously I will help you out and we'll discuss the results and then learn from it, okay? All right, this is Mr. Aynesworth, and once more, this is the prep for activity 3B4, which talks about all the structures that are involved in the important skills necessary or needed in the 3B4 activity. So, all right, good luck. I'll see you in my next lesson. Bye-bye.